Oh, this is so neat. I'm loving that biology in the background here. Okay, so in this first blank, guys, you want to put parametric equation uses one parameter, usually t. To describe x and y independently using two different equations. The graph is limited by the interval of t and it also has direction. Okay, we're not going to do all these first three examples because it's just teaching you how to graph, and we're going to get down to the graphing part. But it says, find the x and y coordinates of the given set of parametric equations given this time. This is the equation for x equals, this is the equation for y equals, and we won't know what's going on at t equals 2 seconds in this problem here. So basically what you do is you take 2 and plug it in for t. X equals 3 times 2 minus 1, x equals 6 minus 1, x equals 5. Y equals negative t squared plus 5. Now there's a negative in front of that t, so what do you have to keep in mind there, Zach? And there's a negative right there, buddy.
The sign.
Yes, like you got to square and then multiply it by what?
Negative.
Very good. So you got negative 2 squared is 4. That's going to give me negative 4 plus 5. Y equals 1. So the point I would graph, guys, would be 5, 1. Alright, so we want to start practicing how to graph the parametric equation. Okay, so they give you your interval. Now you say, okay, Mr. Esther, t represents time, and we have from negative 2 to 3. What does that negative? We don't have negative 2 seconds. I researched this last night because I knew common ground was going to say, how do we have negative 2 seconds? It talks about, the best way I could explain it was that deals with what was going on before the projectile was shot. Those 2 seconds before the thing actually took place. I went, okay. Yes, that's what's going on during that time. Okay. So here's your interval from negative 2 to 3. So you put that in your t. Does it not just seem surreal we're in this building today? Like, you have the most beautiful building in the state of Alabama, the most beautiful high school. Look at the mountains. I feel like I'm in the Smoky Mountains. Just look at the, I'm seeing them between the hills of Celeria right here outside my window. You see that? I know. Don't ruin the moment, Zach. Don't ruin the moment. I'm sorry all these comments are hearing this video. All right, here we go. Now, let's get back. Now, I'm going to plug negative 2 in for x. Now, you are all intelligent, or you wouldn't be in this class. We can do this here. What's negative 2 squared? 4 minus 4 is? Plug negative 2 in. You're getting your x. So I'll plug this in. And negative 1 squared is 1. 1 minus 4 is? Negative 3. 0 minus 4 is? Negative 4. 1 squared is 1 minus 4 is negative 3. 2 squared is 4. 4 minus 4 is 0. 3 squared is 9. 9 minus 4 is 5. Now I'm going to plug this into my y formula. Negative 2 divided by 2 is negative 1. Negative 1 divided by 2 is negative 0.5. Or you can put negative 1/2. 0 divided by 2 is 0. 1 divided by 2 is 0.5. 1 and then 1.5. So guys, what you actually graph is these order pairs. You don't use the t, you graph those order pairs. So I have 0, negative 1, negative 3, 0.5. Oh, right here, sorry. Negative 4, 0. Negative 3, 0.5. Well, that worked out well. 0, 1. And you graph it in the order you graph the points. So that is your graph. Now, what makes this different? You got to go back in there and draw some arrows somewhere showing that you're showing which direction this thing went. It doesn't matter where you put your arrows, but you show that that is the way the projectile was going. Now, do you think you need to put an arrow at the end thing right here to show that it keeps going? Yes or no? No, because you're only concerned with that interval right there. Does that make sense? You don't want to go, you don't make a mistake and just put a dot there at the beginning and end. That's only the interval you're focusing on right now. Okay? But this is why we study in vectors, because vectors have both magnitude and what? Direction. Pure metric equations have direction. That's why this is in the vector unit. Alright, I want to skip number 5 because it's very similar to number 4. Let's go to number 6. Okay, there's not an interval here. I forgot to put that here, so let's make one. It's going to be negative 2 less than or equal to x less than or equal to 2. Alright, so what will go in my T-box, class? Negative 2, what else? Negative 1, 0, 1, and 2. Now, I won't have these charts on your homework. You don't have to draw your little charts. But, and when you draw one, all it has to be is something like that, okay? Tx and y. You have to have the three grid lines. Ooh, focus, focus. Oh, look how quicker that was in the old machine. Alright, now, I'm going to plug negative 2 in for my x formula. That gives me negative 3, negative 2, negative 1, 0, and 1. Plug that into my y values. Negative 2 squared is 4, negative 1 squared is 1, 0, 1, and 4. Remember, this is what I graph. I graph these ordered pairs. Negative 3, 4, 1, 2, 3, 1, 2, 3, 4. You're correct. I messed up. Hold on. Let me fix that. Thank you. I knew it was looking weird for a minute. Made a mistake. So let's see here. Okay, because it's at, where was that? 0, 1, so it should be right here. Thank you. Do you see how I drew my arrows there? Are we good on that one? Alright, next one, number 7. When you have something like this from 0 to 2 pi interval, what do you think you would use as your points? Those major ones. That's what I would use. 0, pi over 2, pi, 3 pi over 2. Does that make sense? Are you sure? Alright, so I'm going to use 0, pi over 2, pi, 3 pi over 2, and 2 pi. I use 2 pi because it says less than or equal to. If it had just said less than, I wouldn't have used it. Alright, now I'm going to plug this in. Let's do it together. Let's make me smile this morning. Here we go. You ready? I plug 0 in. Sine of 0 is? Sine of 0 is?
1. No, 0. 0.
Are you serious? I only have 3. No, it is 0, but why am I only having 3 people answer that right now? What is sine of 0? Can you have a negative 0? No, so it's just 0. Okay, I'm gonna get your thoughts together. Picture in your mind. Here we go. If you don't, I'm going to knock your tree quiz down to 2 minutes come tomorrow if you don't do this. So right now it depends on the law what you do right here. Sine of pi over 2 is what?
1.
Sine of pi over 2 is?
1.
There's a negative, so it would be negative 1. I better see everybody's mouth move when I ask the next question. Sine of pi. 0. You don't have to worry about the negative. Sine of 3 pi over 2. Negative 1, but since there's a negative there, it makes it what? Sine of 2 pi is?
0.
Okay, now, let's go to cosine. Cosine of 0 is? 1. Since there's a negative out front, that would be negative 1. Cosine of pi over 2 is? 0. You don't have to worry about it. 0 can't be negative. Cosine of pi is? Negative 1. Because there's a negative there, it's going to be what? Positive 1. Cosine of 3 pi over 2 is? Cosine of 2 pi is? 1. Since there's a negative, it's going to be negative 1. Now let's graph this. 0 and negative 1 is right here. What do you notice? It just forms a what? Circle.
It's like the unit circle.
Man, that's amazing, isn't it? That's your graph. Just went around like a merry-go-round. No. Yeah, you're right. Mm-hmm. Alright, now, the next part of the lesson, this is real easy. It's called eliminating the parameter. How do you get rid of that third variable, t? Eliminate the parameter. This is probably the easiest thing today. Okay, well, first thing you do is you solve the equation for t, and I always start with the x equation. X equals square root of t. You want to get t by itself. How do I get rid of that square root? Square. Both sides. X squared equals t. Now you take this guy, since t is equal to x squared, take x squared and plug it into t in the other one. Therefore, have you eliminated that third variable? T. So first thing you do is you get t by itself, and since you're trying to get rid of this t, you take what t is equal to and plug it in for t in the second equation. On number 9, I want to get t by itself, so the first thing I'm going to do is move over the what? That becomes a positive 1. Alright, now I'm going to take the square root of that. Now, take this, since that's equal to t, and plug that in. No, you don't. You like these problems? Number 10. How am I going to get t by itself? Add what? 2. Add 2 to the other side. Now take that. You say, Mr. Chester, do we need to foil all that out? No, I'm good with that, guys, because you're just trying to eliminate t, okay? I won't make you work all that out. Now, if you did, it wouldn't be wrong, okay? And number 11. Move that over. Divide both sides by 2. So y plus 4 over 2 equals t. Now take this. Oh wait, this is supposed to be an x right here, guys. I'm sorry. Change that to x. So that's looking weird. And you said, Mr. Chester, do you want us to have to foil that complex fraction out? No, you just you're just eliminating the variable. And that's our lesson for the day. Do you understand your learning target? I need a hand signal. Okay. You have 8 minutes to work on your homework. Let's look at our homework and make sure we understand it. It is page 12. Do number 46. 47, 49, 51, 52, 53. That's 6 problems.
Are we supposed to do something listing that?
Yeah, go put it on that chart paper up there. What are parametric equations? If you, juniors, if you have a sticky note, put that on that chart paper right there. And then starting homework. You better write something type big T. Oh, I better close this out before I say anything else.
Hey, do you have any graph tape?
I can get you some in just a second, buddy, okay?
Okay.